Hello everyone, so today I'll be explaining question number 29 of Set 2 GATE Civil Engineering 2021. A frame EFG is shown in the figure. All the members are prismatic and have equal flexural rigidity. The members FG carries a uniformly distributed load W per length. The axial deformation of any member is neglected. Consider the joint F being rigid. The support reaction at G is. So we need to find the support reaction at G. 4 options are given to us. It's a 2-mark question. For more understanding on this type of problem, you can refer to lecture series on Structural Analysis 1 by Professor Amit Shaw, Department of Civil Engineering, IIT Kharagpur. Now let's move towards the solution of this problem. So there are many methods to solve this type of problem, but here I'll be using the standard deflection formulas to find the support reaction at G. So how to do that? For this, we will decompose our main structure, let's call it as structure 1, into 2 parts. Let's call it structure A and structure B. Structure A carries the external load and structure B contains the support reaction. If we will add these two structures, we will get our final structure back. So this means that we can decompose this our main structure into this 2 type of substructures. Okay, so let's see what is the deflected shape for these 2 substructures. For structure A, the column will deflect like this. Since it has to maintain 90-degree angle at F, since the joint F is rigid, so we will draw this shape. Again, due to the external loading, the beam will deflect something like this. So in all, there will be 2 deflection. Let's call it as delta 1W and call this deflection at delta 2W. Similarly, we will see structure B. Let's see how it is getting deflected. So for this type of load, point load, let's see the deflected shape. So the column will deflect like this. Since the joint F is rigid, we have to maintain a 90-degree angle. Hence, the shape will be like this. Again, due to this this point load, the beam will deflect like this. So in all, the structure will have deflection. Let us call it as delta 1R, and let's call the another deflection as delta 2R. Now final deflection at point G due to structure A will be delta W, which is the sum of delta 1W plus delta 2W. And final deflection at structure B, at point G will be delta R, and it will be equal to delta 1R plus delta 2R. In order to satisfy the compatibility condition, we know that the support G is not going to move, right, since it is supported. So there will be no deflection at point G. This means that delta W should be equal to delta R. So this is our final equation which we have to use. We will equate delta W with delta R, and finally we get our value of support reaction R. Let's calculate the value of all the parameters one by one. First, I am going to calculate the value of delta 1W. So for this, I'll make the deflected shape again for structure 1. So it will go like this. Since it has to maintain the 90-degree angle, it will be like this. So we need to calculate this value of delta 1W. Let's say this is theta, this angle is theta. Therefore, this angle will also be theta. Hence, the value of delta 1W will be equal to theta multiplied by this length L. Okay. For calculating delta 1W, we need to get the value of this theta. So let's find out the value of this theta. I'm making this column FE again. So FE is subjected to a moment. That value of the moment is due to this loading W. The value of this moment M is W into L by 2. The value of this moment will be WL square by 2. For this type of loading, we know that the standard deflection formula for theta, that slope we will calculate it as M, length of this column, which is 2L by EI, right? The value of theta will finally be WL square by 2 multiplied by 2L divided by EI. Hence theta will be equal to WL cube by EI. We will calculate the value of theta delta 1 W as theta multiplied by L. Theta we already know, WL cube by EI multiplied by length. Hence finally we get our value of delta 1 W as WL 4 by EI. So we get the first part of our problem, delta 1 W equal to WL 4 by EI. So now let's quickly calculate the value of delta 2 W as well. So in addition to delta 1 W, there is an external load W, and due to which the beam will deflect like this. So this was our delta 1 W, which we have already calculated, and this is the value of delta 2 W, which we have to calculate. Now delta 2 W is same as this case. So since this beam is already there, so since this support is rigid, we can consider it as like this, and the deflection due to this UDL is nothing but delta 2 W, this part. So delta 2 W will be equal to, from our standard deflection formula, it will be equal to WL4 by 8 EI. Here the value, hence delta 2 W is equal to W, length of this beam is L, and 8 EI. So total deflection at point G due to external load will be delta 1 W plus delta 2 W. The value of delta 1 W is WL 4 by EI, and delta 2 W is WL 4 by 8 EI. Hence the final value of delta W will be 9 by 8 WL 4 by EI. Similarly, we will calculate delta R. Let me first draw the deflection diagram. So the column will deflect like this, and it will make a straight line from here. This is delta 1R, and we will first calculate the value of delta 1R. Let's call this angle as theta, therefore this angle will also be theta. The value of theta will be ML by EI. In this case, let's see what is the value of M. The moment here will be due to this point load, and the value of this moment is R into L. Therefore, we will calculate theta as R into L multiplied by the length of this column, which is 2L, divided by EI, which is the flexural rigidity of the column. So theta will be 2RL square by EI, and consequently we will calculate the value of delta 1R as theta multiplied by L, which is delta 1R will be equal to 2RL cube by EI. Now let's calculate delta 2R. let me draw the deflection diagram again. So this is the deflection of the column, straight line from here, and due to the point load it will again deflect like this. So this is the value of delta 2r. The value of delta 2r will be simply calculated as, this is the case of this beam, and the deflection here can be simply calculated as PL cube by 3EI. Load is R in this case, so R L cube by 3EI. We have the value of delta 1r and delta 2r. Let's calculate the total deflection delta r as delta 1r plus delta 2r. Delta r will be, delta 1r was 2RL cube by EI, 2RL cube by EI, and delta 2r is RL cube by 3EI. So our answer will be 7RL cube by 3EI. Now we have the value of delta R as well as delta W. So we will apply our compatibility condition now. We know that the point G will not move anywhere as it is supported. Therefore, delta R should be equal to delta W. Delta R we calculated as 7 by 3 RL cube by EI, and delta W we calculated as 9 by 8 WL4 by EI. So we are putting the value of delta R and delta W here. From this we get the value of R as 27 by 56 WL. We can also write it as 0.482 WL. Hence this is our final answer in this case. The value of R is 0.482 WL, which is our option number C.